Imagine wrapping an entire star in a giant shell, not a metaphor, not science fiction. An actual physical structure, 300 million kilometers wide, built by a civilization so advanced that wasting a star's energy would be like leaving your lights on forever and calling it acceptable. That is a Dyson sphere. And here is the part that should keep you up at night. We may have already seen one. The idea. In 1960, physicist Freeman Dyson published a paper with a deceptively simple premise. Any civilization that survives long enough will eventually run out of energy on its home planet. And when that happens, there is only one logical move. Go bigger, way bigger. His idea: build a structure around your star. Capture every photon it emits, every single one. Our sun puts out 3.8 times 10 to the 26th watts every second. That is more energy than humanity has used in all of recorded history, released every millisecond. A Dyson sphere would harvest all of it. Now, Dyson himself did not imagine a solid shell. He thought a swarm of satellites orbiting the star made more physical sense. But the solid sphere version is the one that captured our imagination. And honestly, both ideas raise the same terrifying question. If another civilization already built one, what would it look like from Earth? The physics problem. Let us talk about why building a Dyson sphere is almost laughably difficult and why that makes it so fascinating. First problem, materials. A solid shell around our sun at Earth's orbital distance would need to be roughly 600 quintillion square kilometers. For scale, that is about 100 million times the surface area of Earth. You would need to dismantle entire planets, possibly Jupiter, just to get enough raw material. Yes, I said, dismantle Jupiter. And the shell itself, it would have zero gravitational stability. A solid Dyson sphere does not orbit a star. It just floats there. One small gravitational nudge, and the whole structure drifts directly into the surface of the sun. This is why engineers who have actually modeled this prefer the swarm concept. Thousands or millions of independent solar collectors, each in its own stable orbit. No single point of failure, no catastrophic drift. Just an ever-thickening cloud of energy collectors, slowly blocking the star's light. Second problem, heat. A structure absorbing that much stellar energy has to radiate it somehow, or it melts. A Dyson sphere would glow in infrared radiation, re-emitting heat outward into space, which means it would look completely invisible to the naked eye, but blindingly obvious to an infrared telescope. And that detail becomes very important. The real twist. Now remember that opening line. We may have already seen one. In 2015, astronomers noticed something strange about a star 1,500 light-years away, KIC 8462852, nicknamed Tabby's star. The Kepler Space Telescope was watching it, and it kept dimming, not the small, regular dimming you would expect from a planet passing in front. Huge, irregular dips, sometimes blocking 22% of the star's light. That is enormous. Jupiter, the biggest planet in our solar system, would only block about 1%. The dimming had no obvious natural explanation. Dust clouds, too variable. A giant planet, wrong pattern. And then astronomer Tabitha Boyajian, the star's namesake, mentioned the idea almost reluctantly in an interview. What if it was a Dyson swarm under construction? The internet lost its mind. SETI pointed radio telescopes at it. Headlines screamed, alien megastructure. And then, follow-up, research suggested the most likely explanation was probably a swarm of comets. Or dust. Probably. The truth is, we still do not fully understand what is causing the dimming. The alien megastructure hypothesis has been largely set aside by scientists, but it was never definitively ruled out. It just became the least likely explanation among several unlikely explanations, which, in science, is how things often work. You do not get a dramatic answer, you get a quieter mystery. Could we build one? So could humanity ever build a Dyson sphere, realistically? On the Kardashev scale, a framework for measuring a civilization's energy use, we are currently at type 0.7, A Type 1 civilization controls all energy on its planet. Type 2 controls all energy from its star. A Dyson sphere is the defining achievement of a Type 2 civilization. At our current energy growth rate of about 1 to 2% per year, physicist Michio Kaku estimates we could reach Type 1 in a few hundred years. Type 2, Dyson sphere territory, would take thousands of years. But here is the thing. We are not trying to build it all at once. We could start small, a few satellites, a swarm around Mercury, which is closest to the Sun, expand outward over generations. The technology required is not magic. It is solar panels, orbital mechanics, and robotic manufacturing. Scaled up by factors we can barely imagine. Yes, but not fundamentally impossible. The Dyson sphere is not a fantasy. It is an engineering problem. A very, very large engineering problem. Here's what strikes me most about the Dyson sphere concept. It forces you to zoom out, not just from Earth, not just from our solar system, but from our entire sense of what is possible. Freeman Dyson did not write his paper to describe alien civilizations. He wrote it as a search strategy. If something like this exists out there, we now know what to look for. A star that has gone quiet in visible light, but screams in infrared. We have not found one yet, but we have only just started looking. So here is my question for you. If humanity had the technology tomorrow, would we actually build a Dyson sphere? Or would we decide some things are too big to touch? Drop your answer in the comments. If this blew your mind, subscribe. New videos every week, because the universe is full of questions like this one, and we are just getting started. Stay curious,